Hello everyone, welcome to my YouTube channel Shilpa Data Insights.
In this video, we are going to see what is a DAG. In the previous video, we have seen what is an RDD, what is a data frame, what are the transformations and actions in the Spark. So in this video, let's see what is a DAG. DAG is directed acyclic graph. So it is basically a graph which has vertices and edges. So whenever you will see a graph, you will have your vertices and you will have your edges. And it is a directed graph. It means to reach one point, there is a direction. So every edge will have a direction and it is acyclic, means there are no cycle. To reach a path or an edge, you need to traverse through one particular path. What is a spark DAG? So DAG is a graph, so it has a vertex and an edge. So Spark DAG is a logical flow of a graph which has the operations shown in it. So whenever you are performing some operations, those operations are displayed as a logical flow of operation, and it contains some stages and some tasks. So basically, it contains a chain of RDDs and their dependencies which are organized in a form of a DAG. So it will have list of all the operations like your transformations and actions present inside the DAG itself. So how exactly the DAG looks like? Let's say I have an RDD1 and I am doing some transformation, let's say a filter operation, then it is going to create an RDD2. On the top of that RDD1, I am doing some more operation and it will create an RDD3. Now let's say I want to go ahead and combine these two RDDs, that is RDD2 and RDD3, to create one more RDD, which will be RDD4. So this is how exactly it will be created in the DAG format when you are calling some action or a transformation. Now, why the DAG is needed? So basically, when you are creating a DAG, it creates a plan, it creates a logical plan, and then it creates a physical plan. That physical plan is an optimized plan. So whenever you are calling an action, it creates an optimized plan, and then the complete action takes place and gives you the result. And it also helps you with the fault tolerance. Let's say an RDD is lost in between. So how will you recover that RDD? It will be recovered from the DAG itself. So as the Spark performs lazy evaluation, it will allow you to get the complete flow of operation, and whichever RDD is lost, it will go ahead and regenerate that RDD and give you the complete result. And whenever there is some shuffling, right, it will also reduce that shuffling. How it is done? It is done because you are creating a complete graph, a complete plan. In that physical plan that is created, it sees what is the optimized plan. And according to that optimized plan, it will reduce the shuffling and give you the output of the result. I have a file in which I will be doing some transformations and actions, and I will show you how the DAG looks like. So now I'm importing some functions and I have two CSV files. I'm going to read those two CSV files in DF1 and DF2. Now I want to go ahead and filter out the data which has the department ID from the first CSV file and the same from the second CSV file. So I will be filtering out this particular data, DF3, in which I will only have the department as ID. Same goes for the next data frame that I will be creating, that will have only the department ID. I want to go ahead and union both the data. So for that, I will be using my both the data frames and unioning it up. So union DF is now df3.union df4. From that union DF, I want to get how many employees are belonging to a particular department and I have filtered out the IT department. So it will give me the count of IT department, how many employees are working in it. So I have this final DF in which I'm getting only the department and the count of the employees. So now if you will see in this particular DF1 and DF2, there was a Spark job created because it's reading the file. Now, if you will see in this DF3, it is filtering it out. So there is no job created here because this is a transformation. Now, and in this particular union also, this is a transformation and no job is created. Okay, group by is similarly transformation. So whenever there is a transformation, only the lineage graph is created. Unless and until you call an action, the DAG is not created. Once you call an action, then only the DAG is created and you will get the output. The DAG will help you in calculating all the transformations that is being called. So now I am going to display what is the output of this final DF. So this is an action and now you will see the jobs are created and it gave me the out DAG, how exactly the DAG looks like. So this is my particular job, job 3, and I have these two queries. In this, I have this DAG visualization. If you will see, the first file was scanned and then the second scan file was done. And after that scanning, the union operation was done. And after that union, it is stored in the exchange so that this exchange can be reused for the group by operation. So here a shuffle was made. So I will explain you what is this AQA shuffle bead in the coming videos. So a shuffling is done, and after the shuffling is done, it is given back to us as an output. So this is how exactly the DAG looks like. Why the stage was skipped is because in the first data frame itself, we already scanned the CSV file. So this stage was basically skipped and the stage 4 was actually evaluated. So if you have not seen my video of stages and action, just go ahead and see that. You will understand how exactly the stages and actions are created. And it is created with the help of this DAG. So this particular DAG, you should be able to know and how to read this DAG. So that if in case there's any problem or you want to optimize it, you can go ahead and easily read the DAG and do your optimization and solve your problems. So this is our complete stage. So here it says how much time it took to go ahead and create the data and give you the output, and how many tasks was there, and how many shuffle read was there, and how many shuffle write was there. So this is how exactly the data or the DAG of the data looks like. I hope you have learned something new and you have understood what is a DAG and how exactly to read the DAG, what is the advantage of a DAG. If you like this video, then hit the like button, share it with your friends and subscribe to my channel.
Thank you so much for watching, and I wish you have a good day.